Yes, good morning to one and all. Am I audible? Yes.
Yes, sir.
Okay. So last class we have seen that corona discharge and numerical on it. Okay. So formula for the critical disruptive voltage, visual critical voltage, power loss due to the corona discharge, and factor affecting the corona discharge. These are the very important concept. Okay. You should remember. Okay. So today we will start sag in transmission line. I think in last class we have seen the definition for the sag in transmission line. Okay. So sag in transmission line, as I said earlier, it is the vertical distance between lowest point on the conductor and point of support of the particular conductor. Okay. Yes, am I audible?
Yes, sir.
Okay. So sag in transmission line is nothing but what? It is the vertical difference in a level between points of support and lowest point on the conductor. Okay. So as we know that our overhead line conductors are tied at the support, okay, to the cross arm by using the suspension insulator or sometimes pin insulator, okay, or string of suspension insulator. Okay. Uh, so sag is nothing but what? It is the vertical distance or difference between lowest point on the conductor and the point at which that particular conductor is tied to the cross arm. Okay. So before that, uh, some important points we have to note. Okay, like that the conductors are supported on insulator which are fitted or tied on the cross arm of poles. The conductors between the support of two poles are stretched. Okay, as we know that, look at this diagram. Okay, our overhead line conductors are fitted on the cross arm. Okay, uh, so see over here, in this case, over here, we have used a pin insulator. Okay. For example, okay. So this live conductor or line conductor is tied or fitted at a top point. Okay. Suppose this is a cross arm. Okay. Or the insulator. Okay. On which the our overhead line conductors are fitted. Okay. So second point is that if we stretch this line conductor straight, okay, at that condition it will create a large tension and conductors may break. Okay, if we do that conductor stretch or straight line, so in that case there will be a chances to break that live conductors or the line conductors because of the various factor. For example, ice loading is there. We can say that wind blow is there. Okay, because of that one, the large tension will be created on that line conductors. Okay, so there will be chances to break the conductors. Okay, to avoid that one, we have to provide a uh, deep, or we can say that sag to the overhead line conductors. Okay, so in order to permit the safe tension, okay, these line conductors should not be stretched fully. Okay, but allowed tension should be there in that live conductor. Okay, so generally the sag, it will be depends upon span. Okay, so see over here, the span means what? Okay, and also it is depends upon the ground clearance. Okay, so see this diagram. Okay, from this diagram, schematic diagram, you will get the idea for the sag. Okay, so see over here, this A and B point represents the line conductor at which the fitted to insulator. Okay, this A and B point. Okay, this is nothing but the support point for the line conductors. Okay, so over here O point represents the lowest point on the conductors. Okay, lowest point on the conductors. If we measure the vertical distance between this O point and A point, or vertical distance between B point and O point, it will represent the sag. Okay, it will represent the sag. Okay, have you got the idea what is meant by the sag actually? Yes, tell me.
Yes, sir.
So uh, before that, we will summarize various span for the different types of supports or the poles. For example, wooden poles span in meters, 40 to 50 meter will be there. Okay, 40 to 50 meter span should be in case of wooden poles. Okay, if these two supports are wooden, we can say that in that case span should be 40 to 50 meter. Okay, means what, near about 120 feet to 150 feet. Okay, between these two supports, म्हणजे दोन पोल मधलं डिस्टन्स हे वुडन पोल टाईप मध्ये 40 ते 50 मीटर एवढं असतं. ठीक आहे, आता हे मी तुम्हाला स्पॅनच एक्स्ट्रा का सांगतोय, कारण हे मेनली सॅग हा स्पॅन वरती डिपेंड असतो. परत दुसरी गोष्ट आहे की ग्राउंड क्लिअरन्स किती ठेवायचा आहे, म्हणजे इनडायरेक्टली ते वर्किंग व्होल्टेज वरती पण डिपेंड असेल. ठीक आहे, नंतर आहे बघा स्टील ट्युब्युलर पोल्स. ओके, स्टील पोल साठी ट्युब्युलर पोल्स म्हणजे पाईप लाईक स्ट्रक्चर. ओके, त्या केसमध्ये 50 टू 80 मीटर्स स्पॅन लेंथ असते. ठीक आहे, आणि आरसीसी पोल्स, in case of RCC pole, the span 80 to 200 meter. Okay, 80 to 200 meter span length should be there in case of RCC pole. Okay, next, steel towers. Okay, steel towers 100 meter to 300 meters. Okay, 100 meter to 300 meters. Okay, so in order to decide the span, the some important factors we have to consider. Okay, first one is whether the our transmission line or distribution line crossing a river or nala. Okay, or if it is crossing the railway line. Okay, big obstacles like mountains. Okay, or sometimes our transmission line or distribution line crossing the highways. Okay, 3 lane, 4 lane, 6 lane highway. In that case, span will be varied. Okay, canal crossing. Means what? Sometimes our distribution or transmission line going to cross the canals. Okay. Next, turning off line. Okay, means what? Uh, if you want to turn the transmission line or distribution line, span will be varied. Okay, according to the turning of transmission line or distribution line. Okay, so be remember that span of the transmission line or distance between the two supporting structure of the live conductors or transmission line conductors mainly affected by whether the given transmission line crossing the river, railway, big obstacles like mountains or hill, okay, uh, road, canal, and turning off line. These are the main important point to be considered while deciding the span between the two supporting structure. Okay, or sometimes diversion or splitting of line also going to affect on that span length. Okay, and termination of line. These are the various 6 to 7 parameters we have to consider while providing the span for the towers, or we can say that poles. Okay, so once again I will repeat. In case of wooden pole, 40 to 50 meters should be there span length. Okay, or distance between the two pole or two vertical structures. In case of steel tubular poles, 50 to 80. In case of RCC pole, 80 to 200 meter, and steel tower 100 to 300 meter. Okay, this data is very important while attending that state PSU like MSCB and all. And also if you facing some uh, industrial interview, in that case they will ask you, or there is a major chances to ask the question on this area. Okay, so be remember that the range for the span for various types of supports. Okay, so I hope the concept of sag in transmission line is clear to you. Whether it is clear or not, let me know. If it is not, means please uh, ask doubt. Whether it is clear to all? Yes, yes. Am I audible to all? Yes, please reply anyone.
Yes, sir.
Okay, I hope no doubt regarding this one. Okay, so we will see that what are the various factors on which our sag will be depends. Okay, I have told you in introduction the major um factor going to affect on the sag of transmission line is span length. Okay, span length. Okay. Next, weight of the conductor. Okay, second point is what? Weight of the conductor. Third, we can say that working tensile strength. Okay, working tensile strength, it will also going to affect on sag of transmission line. Next, temperature. Okay, next, formation of ice or ice loading. Okay, next, wind blow or wind speed going to affect on the sag. Okay, so one by one we will discuss. Okay, so weight of the conductor. Okay, weight of the conductor. Heavy conductor means more sag. Okay, see over here, if our line conductor is heavy, in that case सॅग विल बी मोर. ठीक आहे, सिंपल कॉन्सेप्ट आहे ही. जर वेट ऑफ द कंडक्टर per unit length, if the weight of conductor for their per unit length will be more, means what? In that case sag will be more. मला काय म्हणायचंय बघा, जर पर युनिट लेंथ वर साठी जर पर्टिक्युलर कंडक्टरचं वजन हे जास्त असेल तर त्या केसमध्ये सॅग हा जास्त असतो. ठीक आहे, सॅग जास्त असतो म्हणजे काय की हे यस जे डिस्टन्स आहे, यस इथे मी एरो पॉइंटर स्लाइड करतोय बघा, यस डिस्टन्स जे आहे ते मोर असेल जर वेट ऑफ कंडक्टर लार्ज असेल. ठीक आहे, तुम्हाला याचं डिफरन्शिएटिंग एक्झाम्पल सांगायचं झालं तर बघा, if our line conductor is made up of ACSR conductor, in case of we can say that in first case our line conductors are made up of ACSR conductors, and in second case our line conductors are made up of copper. Okay, so specific weight or weight of copper is more than that of the ACSR conductor. Okay, so in case of copper conductor the sag will be more. आता हे असं कसं काय होतं तर ते आपल्याला कॉमन सेन्स न कळतं की ज्याची स्पेसिफिक ग्रॅव्हिटी जास्त आहे त्याचं वेट जास्त असतं. ठीक आहे, मग ही स्पेसिफिक ग्रॅव्हिटी त्या पर्टिक्युलर मटेरियलच्या डेन्सिटीवरती अवलंबून असते, परत ते डेन्सिटी त्याच्या मासवरती अवलंबून असते, परत त्याचं मास किंवा हे त्याच्या काय म्हणू आपण मास नंबरवर, या गोष्टी एकमेकावरती डिपेंड असतात. म्हणजे स्पेसिफिक वेट ज्या मटेरियलचं जास्त असेल त्याच्यासाठी सॅग हा जास्त असतो. ठीक आहे, नेक्स्ट आहे बघा लेंथ ऑफ स्पॅन. ठीक आहे, आता जर दोन सपोर्ट मधलं जर डिस्टन्स वाढलं, ठीक आहे, किंवा दोन पोल मधलं जर डिस्टन्स वाढलं तर सॅग वरती काय परिणाम होईल सांगा बरं. येस, इन्क्रीज होईल. ठीक आहे, definitely sag will be increased, but in what amount the sag will increase as the length or we can say that span increases. Okay, we will see that relation is there into that. Now you have to consider only whenever the span length increases the sag will be increased. Okay, next, working tensile strength. Working tensile strength, sag is inversely proportional to working tensile strength of the conductor. Tensile strength, I hope have you heard this word tensile strength? This is the concept of, I think, mechanical engineering. What is meant by tensile strength? Tell me. Yes, tensile strength. If tensile strength will be
Yes,
more,
sir.
huh? Yes, bola. Yes, विचारा ना, बोला ना, काय म्हणताय बोला. Yes, yes,
Okay, sir. Continue.
आवाज येत नाही बघा तुमचा बरोबर. येस, थोडं रेंज मध्ये या आणि मग बोला. बोला. Yes, I will tell you. Tensile strength means what? Tensile strength of the material is nothing but what? Under pressure, or we can say that under application of external force, how that particular material going to elongate. ओके, इलॉंगेशन म्हणजे काय की त्याला जर एखाद्या मटेरियलला आपण जर फोर्स लावला तर तो किती ताणला जातो त्याला आपण काय म्हणतो, त्याची टेन्साइल स्ट्रेंथ. ओके, म्हणजे आपण त्याला मराठीमध्ये काय म्हणतात बघा, कंडक्टिव्हिटी,
तन्यता.
हा तन्यता. ओके, गुड. तन्यता म्हणजे त्याला तार कितपर्यंत आपण त्याला ओढलं की त्याची तार बनू शकते. म्हणजे त्याची टेन्साईल स्ट्रेंथ ती. ठीक आहे. मग सॅग हा इनव्हर्सली प्रोपोर्शनल टू टेन्साईल स्ट्रेंथ. ओके, म्हणजे मोर विल बी द टेन्साईल स्ट्रेंथ, लेस विल बी द सॅग. याचा मिनिंग काय आहे बघा, जर एखाद्या कंडक्टरची टेन्साईल स्ट्रेंथ मोर असेल तर त्या केसमध्ये सॅग हा मिनिमम असतो. आता तुम्हाला याचं उदाहरण द्यायचं झालं तर बघा, अल्युमिनियम कंडक्टर आपल्या सगळ्यांना माहिती आहे, बरोबर. आणि दुसरं स्टील कंडक्टर असतात बघा, बरोबर. तर प्युअर अल्युमिनियम कंडक्टर आणि एसीएसआर कंडक्टर. ठीक आहे. तर या दोघांपैकी टेन्साईल स्ट्रेंथ ही एसीएसआर कंडक्टरची मोर आहे. ठीक आहे, कम्पेअर टू अल्युमिनियम कंडक्टर. एसीएसआर कंडक्टर हे सुद्धा अल्युमिनियमचेच असतात, पण त्यांच्या सेंट्रलला एक स्ट्रँड असतो जो की स्टीलचा बनलेला असतो किंवा कास्ट आयरनचा बनलेला असतो, म्हणून त्याची टेन्साईल स्ट्रेंथ ही जास्त असते. किंवा कास्ट आयरनची टेन्साईल स्ट्रेंथ ही अल्युमिनियम पेक्षा जास्त असते. ठीक आहे. म्हणजे आपण सेम डिस्टन्स वरती जर अल्युमिनियम कंडक्टर आणि कास्ट आयरनचे कंडक्टर जर सस्पेंड केले तर सॅग हा अल्युमिनियम कंडक्टरच्या केसमध्ये जास्त असतो. का? तर अल्युमिनियम कंडक्टरची टेन्साईल स्ट्रेंथ ही लेस आहे विथ कम्पेअर टू कास्ट आयरन. ओके, किंवा स्टील. ठीक आहे, समजते ना हा पॉइंट? येस. नेक्स्ट,
Yes, sir.
टेम्परेचर. Length increases with the temperature. That is what linear expansion. So naturally sag increases. Okay, temperature. If you have the keen observation in a summer season, our overhead line conductors, there will be seems to more sag. Okay, in case of summer season, sag is more with compared to winter season. Why it's so? Because of temperature will going to affect on tensile strength. Okay, tensile strength of the material. Okay, as we know that tensile strength increases, sag decreases. Okay, but in summer season tensile strength going to decrease because of the rise in temperature. Okay, tensile strength going to decrease because of the rise in temperature. That's why sag will, tell me, sag, how it will be?
Increases.
Increases.
Increase.
Correct, correct. ठीक है, बरोबर है. Whenever the temperature increases, tensile strength decreases and sag will increases. Okay, remember this point. Next, formation of ice on the conductor. In our region, it is not observable. It is observable in European countries like Switzerland and all. Okay, or we can say that cold place. In that case, the ice loading will be observed. Okay, so ice loading is nothing but what? Deposition of snow on the live conductors or the line conductors. It will causes the rise in per unit weight, sorry, per unit length of a conductor. Okay, म्हणजे एक युनिट लेंथच्या जर आपण विचार केला तर त्या पर्टिक्युलर कंडक्टरचं हे वेट इन्क्रीज होतं जर आईस डिपॉझिशन झालं किंवा स्नो डिपॉझिशन झालं. हे आपल्याला कॉमन सेन्स न कळतं बघा, की जर आपल्या लाईन कंडक्टर वरती स्नो डिपॉझिशन झालं तर त्याचं काय होतं, वेट वाढतो. त्याच्यामुळे काय होईल, मग सॅग हा इन्क्रीज होईल. ठीक आहे, हे काही इम्पॉर्टंट फॅक्टर्स आहेत बघा ज्याच्यावरती की आपला सॅग डिपेंड्स असतो. ठीक आहे. Next, we will see that importance of sag. Okay, or what is the necessity of sag in transmission line. Okay, so tell me, any one of you, what is the need of sag? Yes, yes, tell me. Yes, tell me, what is the need of sag, or what is the importance of sag? Tell me. Yes, Yes, am I audible to you? Yes.
To maintain the stability in support system.
Okay. To avoid the breaking of conductor. Okay. Yes. Good answer. Okay. So sag is mandatory in transmission line conductors suspension. Okay. The conductors are attached between the two supports, as we know that. Okay. So in that case, we have to provide the perfect value of sag. Okay. This is because of it will protect the conductor from excessive tension. Okay. So you have said that me to avoid the breaking of conductors. Okay. So it is caused due to the excessive tension. Okay. So in order to provide the safe level of tension in the conductor, we have to provide the sag. Okay. If the conductor is stretched fully, okay, during installation, wind pressure will exerted on it and the conductor gets chance to broken. Okay. जर आपण इन्स्टॉलेशनचं वर्क करतोय आणि त्याला जर फुल्ली स्ट्रेच केलं कंडक्टरला, तर काय होईल, जर एअर ब्लो आला किंवा खूप जोराचा वारा आला तर काय होईल, कंडक्टर तुटतील, बरोबर. किंवा समटाइम्स काय होतील की इन्सुलेटर पासून डिटॅच होतील, बरोबर की. सो सॅग इज नेसेसरीली प्रोव्हाइडेड इन केस ऑफ transmission line conductors or distribution line conductors. Okay. When the same we have to some important points to be noted. Okay. So when the same level two supports hold the conductor, yes, am I audible?
Yes, sir.
Okay. When the same level two supports hold the conductor, a bend shape arises in the conductor. Okay. Sag is very small with respect to the span of the conductor. Okay. These are the some points. Okay. The sag span curve is parabolic. Okay. Be remember that. I think I have noted for its main motto behind it. MCQ will be frame on this. Okay. The sag span curve is parabolic. Okay. Be remember that. Sag span curve is parabolic. This one is what? A parabolic shape. Okay. AOB. This is what? Parabolic shape. Okay. Next, the tension in each point of the conductor act always tangentially. Tension in each point of the conductor acts always tangentially. याचं मिनिंग काय आहे बघा. हा जो ओ पॉइंट आहे की नाही, सपोज ओ पॉइंट गृहीत धरू आपण, तर याच्यावरती टेन्शन हे टँजेन्शियली, म्हणजे ही जी लाईन दिसते ना, ही अशी हॉरिझॉन्टल लाईन, तिला आपण टँजेन्शियली म्हणतो. ठीक आहे. टँजेन्शियली ऍक्ट होईल. Horizontal component of the tension of the conductor is constant throughout the conductor length. Okay. This one is what actually stress analysis of line conductor. It is studied in civil engineering. Okay. This is not a part of our syllabus. Okay. That's why I only enlisted over here.
Hello, sir.
Yes. Bola.
Suppose two poles are one pole in the down of the hill and the one pole in the top of the hill. How to calculate the span
Yes.
between these two poles?
Simple. It is generally span between the two.
Show the show with diagram on
Okay.
screen.
We will go to that point. Supports at unequal level. Okay, this is our part. Okay, we will go to that part. Okay, but afterwards. Okay. have a look on this diagram. Okay, this is a numerical. This is unequal level of supports. Okay. This is also unequal level supports. Okay, we will go to that article afterwards. Okay, in that case also we have to calculate the sag, and means what, indirectly we can decide the span also. Okay, so while calculating the span, generally it is calculated by civil engineer. It is I think indirect surveying method is there to calculate the span between unequal level supports. Okay, जनरली स्पॅन हा सिव्हिल इंजिनियर डिसाइड करतात आणि अनइक्वल लेवलचा जो स्पॅन आहे तो इनडायरेक्ट सर्विंग मेथडनं कॅल्क्युलेट केला जातो. ठीक आहे, एवढा पार्ट लक्षात ठेवा की डायरेक्ट आणि इनडायरेक्ट सर्विंग असे दोन टाईप असतात. इनडायरेक्ट सर्विंग मध्ये काय होतं की आपण एका पॉइंटला थांबलो तर दुसरा पॉइंट हा आपल्याला इझिली दिसत नाहीये, त्याला आपण इनडायरेक्ट सर्विंग म्हणतो. आणि ते त्यांच्याकडे जे इन्स्ट्रुमेंट आहे त्याचा यूज करून ते कॅल्क्युलेट करत असतात. तो स्पॅन कसा मेजर करायचा, दिस इज नॉट आवर पार्ट. ओनली वी विल गोइंग टू डिसाइड द हाऊ मच sag should be provided in that unequal leveled supports. Okay, span will be measured by civil engineer. Okay, but it is generally measured by using indirect surveying method, I think. Okay, I will ask to my civil engineer friend. Okay, I will respond you. What is your roll number? I will respond personally, or in next class I will respond. Okay. This one is what, unequal levels of supports. Okay, in that case also we have to calculate the sag. Okay, so see over here, the span is how it will be calculated. This capital L represents the span. Okay, I hope your doubt is clear. Whether it is clear?
Yes, sir.
Okay, this case we want to study. Okay, we will study in forthcoming lectures. Okay, so next part, how to calculate the shag. Okay, whenever the equal level supports are there. Okay, generally we have to follow this procedure. Okay, separately we will consider the two cases, level supports and unequal level supports. Okay, so this one is I think level surface. Okay, and this one is unequal level supports. Okay, so when we want to calculate the sag in transmission line, two different conditions need to be considered. Okay, first one, when supports are at equal levels, and when supports are at, or we can say that when supports are not at equal levels. Okay, these are the two conditions we have to consider before calculating the sag in transmission line. Okay, the